Hey, fellow mathematicians! Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. That math class can be less like it has been for so many of us and more like mathematicians working together to learn more math. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
So thanks for joining us. If you have missed the last few episodes, numbers 58 through 60, then you'll miss out on the fact that we've been discussing models, modeling, and all the things. We're going to continue that conversation today. In today's episode, we're going to dive into a specific model that can be a little bit tricky. So let's parse out 10 frames. So for our older grade listeners, what's a 10 frame, Pam?
Okay, so a 10 frame is a structure that helps kids think about our 5 and 10 structure. So picture a rectangle that is cut horizontally in half. So it's got 2 rows and then vertically into 5 sections. So it's got 10 squares in this rectangle, 5 on the top, 5 on the bottom. And in this 10 frame, we can do lots of really nice things. And it's nicely set up to be 10 because it's our base 10 number system. And to have that 10 cut into 5 and 5 because we want kids to be able to think about numbers like 6 as 5 and 1 more. So when we have kids think about 10 frames, we have them fill in. I might have that 10 frame. It's called a frame because it's literally just those lines. That is that rectangle cut into those 10 squares, 5 on the top, 5 on the bottom. And we might have kids fill that in. We might say, show me the number 6. And we encourage them to sort of fill in the top 5 and then 1 more. And so that they can kind of look at 6 as 5 and 1 more. Or they can look at the number 9, fill that in almost any way you want to, as 10 minus 1, right? Because we're going to fill up the whole 10 frame and we're just going to have 1 missing. And so we want to be able to think about that as 10 minus 1. But also, if I filled in the top 5 and then bottom 4, in kind of in a row, then I can also think about 9 as 5 and those 4. And so I'm getting a lot of sort of the structure of 10 and 5 and. Like, how do I think about numbers? Oh, don't let me forget under 5. So if I filled in the first 4, then I can think about that as 1 less than 5 because I sort of get used to the fact that that top row is going to have 5, and when I have 1 less than that, then that's 4. I can also do things like fill in 3, and now I see 3, but I also see the unfilled 2. And so 5 is made up of that 3 and that 2. And so I can keep going. Lots of relationships can kind of sort of start to ping at kids as they study and work with 10 frames. So do we like 10 frames, Kim?
Yes, absolutely.
But Kim, you said they were tricky. What do you mean?
They are tricky. So we don't want to use them for too long, right? Not too long.
Or too much.
Right?
Yeah.
They have some good things about them, but they're not our go-to model.
Yeah, they are a fine model, but not a be-it-end-all model. So in our modeling sequence of podcasts that we've been doing, we've been advocating a paradigm about modeling that is, we start with a model of the situation, then we model students' thinking, and then through lots of time and experience, that model becomes a tool for thinking. But there are only certain models that we advocate that go through that whole paradigm, because there are only certain models that are really good models to be tools for thinking, to be tools in order to think. And sorry, 10 frame, you don't make the cut. You're not one of them. That doesn't mean that you're bad, you're ugly, and that we can never use them, but let's get picky. So Kim, let me tell you a story.
Okay.
I was doing a workshop and I had a principal come to the workshop, which is a little unusual. So I want to give this principal some kudos. He knows who he is for coming. He had a teacher who had come to workshops before and was really advocating for change in the school. And this principal was like, I don't know. I mean, Pam sounds a little crazy. He had some confidence in mathematics, and he said, I'm going to go to the workshop. I'm going to check this out. I'm going to push back on what she's saying. I want to make sure that this is really good stuff. So I love that. I love a couple things about this principal. So he shows up at the workshop. We do a lot of work. He's like, this is amazing. You're going to revolutionize the way we teach. We're going to do this. And he went back to his school. Another thing that I really like about this principal is he was working with some students. So he made time out of his week to work with a couple of students who were having some struggles. And he particularly said, I'm going to work with these students.
That's awesome.
And so yeah, it is awesome. So we respect him for that, right? So he came back to me and he said, Pam, it didn't work. And I'm like, oh, help me. Like, what didn't work? And we had this very interesting conversation where he said, okay, like I went to your workshop. I love all the things. You're going to revolutionize the way we teach math. I went back and I took these kids. They cannot add single digits. So young kids, it's a principal at elementary school. And he said, so I grabbed those kids and I said, all right, you guys, this is what you do. So here's this 10 frame. Now notice you're going to add 7 plus 8. Let's just use that for an example. We're going to add 7 plus 8. So here's a 10 frame and make 7. Do it. And the kids could do that. The kids totally made 7. I said, okay, now here's another 10 frame, make 8. The kids could totally make 8. And he goes, okay, guys, now here's what you do. Like there's 7, there's 8. You just clearly move some from one of these 10 frames into the other one so that it's now a full 10, right? So pick whichever one you want. Let's say that we take the one with 7. It has how many left over? Has 3 empty, right? And so then we have one with 8. And so we grab 3 from the one with 8 and we put it into the one with 7.
Mm-hmm.
Now the one that had 7 is now full. So that's a full 10. And now the leftover one, that one that had 8, we've taken 3 away. And so it has 5 left, right? And he's like, okay, read off the answer. Like there it is. Like you've got the full 10, you got the 5, you got count those. The kids clearly did that. No problem. They were able to do it. They got the answer. And he said, but it didn't transfer. He's like, then I would give them problems to solve and they couldn't do it. He's like, it didn't work. And I was like, oh, okay. Let's parse this out. So Kim, help me parse this out. Like what's going on? All the things that were not quite what we meant.
Yeah. Well, so to begin with, there's a kind of a mentality of I do, you do, or I do, we do, you do, right? A little bit of I'm going to tell you what to do with this 10 frame. And that's problematic.
So it's a procedure. Yeah,
right. It's definitely a procedure. There's also this idea that
before you move on. So let's stay with procedure for just a second. So I give you a 10 frame. I give you 2 10 frames. So I provide them and now do the thing so that you make the 7, make the 8. Now move it's the steps, right? Now, even if you're trying to like, okay, what are we trying to find? Even if you're questioning through the steps, it's this idea of steps
that belong to somebody else, right?
Yeah,
the steps belong to him. And he was trying to tell the steps to somebody who had not yet experienced what it meant to break apart an 8 and give it, right? Like a give and take strategy to give it to the 7 to create an equivalent problem, which is a sophisticated idea.
And who also hadn't like maybe thought about the fact that if I make this friendly 10, then it will be easy for me to see the 10 and that 5 left over and call that 15. If I haven't created that idea myself, then who cares what you just, maybe next time, because I'm following your procedure. So maybe next time I'm just going to bring a couple over. And now I have 9 and I have a bunch left over. And what do I do now? Well, and what he saw is exactly what I'm describing. Then the kids would count them all. And he's like, I'm trying to get him out of counting. And I'm like, yeah, but they don't understand why you created the full 10. He's like, how can you not understand that? It's clear. I told them. So in a huge way, the background behind that is a belief that teaching math is about unzipping kids' heads and pouring previously constructed ideas that I have into your head, and you will be able to latch onto them, make sense of them, and know why to do them. And so it's clear. It's like the math is embodied in this model. Voila, do it. Okay, so that's one. What was the other thing you were going to say?
So the idea that reading off an answer, right, is problematic.
I mean, but Kim, we want kids to get answers. Why is that problematic?
Sure. It's problematic because they're not cognitively involved in the thinking of what's happening in the situation.
Oh, this is so important. I think the first time I heard about this, I'm pretty sure it was Kathy Fosno, was talking about that if you do some stuff and then read off the answer, that is a and these are my words, but that's a ping. That should be a, ooh, wait, maybe I wasn't just mathematizing. That if I get to a place where I'm almost surprised by the answer, where
Yeah.
I've done a bunch of things and it's like, oh, hey, look, there's the answer, means I wasn't using the relationships. Like you said, I wasn't cognitively involved in the relationships and doing something with them to make that happen. I'm sort of like, oh, hey, I did the thing I'm supposed to do. I moved. I made maybe the kid understands I'm supposed to make one of those tens whole. And now I see a 10 and a 5. And so I read off that 15. But I wasn't thinking about how 8 is related to 10 and how 7 is related to 10 and how 8 and 7 were related to each other and how those are related to 15. I was just like doing the thing, getting an answer. Now, if you're new to our podcast, you might be like, I do not understand what's wrong. We got an answer.
Yeah.
You might want to go back. Oh, I don't have it handy. We'll put it in the show notes about the episode where we talk about it's not about answer getting. It's about building reasoning, which leads me to one other thing I want to talk about. So sort of 3 things that kind of just went awry. 1, it was too procedural. 2, you're reading off the answer at the end, which could be a real clue that you were just too procedural. And then the third thing I'd like to mention is that notice that for kids to do that, in order to fill that 10 frame, they had to count one by one.
Yeah.
They had to count 1, 2, 3, 4, 5, 6, 7 to fill that 10 frame. 1, 2, 3, 4, 5, 6, 7, 8 to fill that 8, the 10 frame with the 8. Then I don't know if they counted to move over the 3, probably not. I didn't give you the best example for now, the problem that I'm going to have at the end, because I wish that now they were going to have to count more. The 10 and the 5 is almost too easy to go 15. Let's say that I had a problem like 9 and 7. And so 9, I've moved one over, I've made it 10, and I've left over with 6. Now I've got this full 10 frame of 10, and I have this other 10 frame with 6 in it. But do I know that? And all too often what we have is what his kids were doing. They didn't really understand why they were doing what they're doing. And so they moved things around, and then they just ended up counting one by one all of the counters, not using the structure of the 10 frame to help them see what the final result was.
Right.
So if you, again, are new to the podcast or you haven't remembered for a minute that we have this thing called the development of mathematical reasoning. The development of mathematical reasoning is a graphic where we talk about how we want to move kids from counting strategies to additive reasoning. Well, if I'm doing a problem like 7 plus 8, or what did I just say, 9 plus 7, if I'm doing those problems, ideally, if I've already learned to count, ideally at this point, I'm building additive reasoning, not counting one by one.
Right.
So if I demand that that's how kids solve problems, fill in the 10 frame, fill in another 10 frame, move them, and then see what's left over, kids could be doing an whole lot of counting one by one. In fact, they could be getting correct answers every time, very procedurally, counting one by one. Not what we want. We want kids reasoning about friendly numbers, reasoning about landmarks, and reasoning about the relationships between the numbers, so that then we can use that reasoning for bigger numbers and bigger problems and all the things, because we want to build from additive reasoning to multiplicative reasoning. We can't have kids stuck in counting strategies when they should be thinking additively.
Yeah. So I want to consider, though, for some of our really young learners, right? Some of our pre-K and kinder, there are good ways to use a 10 frame. And it's all about when they're learning to count, right? Making sense of the 5 structure and the 10 structure that's kind of embedded in this 10 frame. And it does allow kids to start using the structure. It kind of naturally pushes towards that 5 and 10 structure instead of counting one by one, which is the very beginning of additive thinking.
Yeah, and so some great things that you can do is do some quick images where you show kids and you're like, whoa, how did you do that? If it's quick enough, then kids don't have time to count one by one. And so they start to be nudged a little bit towards, like, how can I use the 10 structure, 5 and 10 structure to help me see those numbers? You can even do that with multiple 10 frames. So those would be fine things. You could have kids when they're learning to count. And so they're using counting to solve problems. 10 frames are fine things for them to sort of organize their count. It helps with one-to-one correspondence. It's all about when kids are learning to count, we are okay with you using 10 frames. When kids are learning more additive thinking, then we don't want you to fill the frame. Don't have kids fill the frame. Then really use quick images. And that's kind of, you'll have to show me another way to use it. I can think of one other way. Bridges in Math uses 10 frames one other way, where kids are learning additive reasoning, where they will show kids not necessarily in a quick image, but they'll show them, like I think they have muddy windows on a bus,
Yep.
where they'll have a double-decker bus that where you can see they've got it's basically kind of 10 framey kind of a thing, and some of the windows have mud on them, and so you can't. Yeah, it's like how many windows are there? Is it how many kids can you see? I can't
Yeah.
remember.
Yeah.
Is that how many kids you
I
can
think
see?
so.
And so that you're sort of using the structure, and kids could count, but because some of the windows are muddy, then you're sort of like, ooh, can I count behind there? And they mud out not just the windows, but like the whole area. So you can't go 1, 2, 3 because it's like just this blob of mud. And so now you have to go, ooh, well, if I'm looking at this 10 frame, I have to sort of know what's there and then extrapolate what's not there. Those are fine ways to use 10 frames when kids are thinking about building additive reasoning. Without, it's all about, you don't want to force kids to have to fill the 10 frame
Right.
counting one by one. That's the big
Right.
idea.
Well, and I was going to say that in that context of the muddy windows, that the kids are, it's given to them. The kids are not filling
Good
something
point.
one
Good
by one.
point.
I think that's a good distinction.
Yep.
So it's all about representing a number and not doing stuff with the number, right? When we would want to use a 10 frame,
Yeah.
once we
yeah.
need them to compute with that number, then we need a different tool. And we're going to suggest that it's a number rack and then an open number line.
So we've talked about number racks a little before. Number
Mhm.
racks are also called reckon racks. Like you just said, those are our preferred tools: number racks and open number lines. Once kids need to compute.
Yeah. So far in this series, we've talked about some models that we think are really good for using because they become really good tools to reason with. And that's going to be a number rack, an open number line, and ratio tables.
Those are some of our favorites. Maybe
Yep.
not all of them, but definitely some of our favorites.
Sure.
Okay, everybody. Next week, in the next episode, we are going to tackle some of the most controversial models. Ta-da! So stay tuned. You are going to love or hate maybe that one. It's going to be really, really good. So we want to encourage you guys to pay attention to the next one because controversy is coming. So, if you want to learn more mathematics and refine your math teaching so that you and your students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable.